With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is, which of the following explains the fact that the reactions of high molecularity are rare? Okay. Now, how do you define the molecularity of a reaction? If we talk about molecularity, then it is defined as the total number of reactant molecules taking part in a reaction, right? So basically, molecularity is the total number of reactant molecules that are taking part in a chemical reaction. For example, we have any general reaction that 2A plus B is combining to form C. So in this case, 2 molecules of A and 1 molecule of B are combining to form C. So total number of reactant molecules involved are 3. So the molecularity of the reaction is going to be 3. If this reaction would have been A giving B plus C, so here only 1 reactant molecule is involved, so the molecularity of the reaction will be 1. This is how we define the molecularity of a reaction, right? So what really happens is that suppose in a container wherever the reaction is taking place, you have molecule of A and molecule of B combining with each other, right? So basically when A and B are there in the vessel, they will approach towards each other and they will collide, right? And they will collide and lead to the formation of AB. This is how the collision will take place. Okay. So what happens is that if in a container you have 3 molecules, right? A, B, and C. The possibility of colliding all, the possibility of collision of all of these 3 molecules is very, very less. Because what are the possible collisions that can take place in a container where you have A, B, and C molecules? A can collide with B. B can collide with C. C can collide with A, and other possibility can be that all A, B, C are combining with each other. So if we talk about all these 3 molecules, the probability of the collision of these 3 molecules is going to be 1 by 4. Out of these 4 collisions, only 1 collision is the one in which all of these 3 molecules are combining together, right? So therefore, if we talk about high molecularity means more number of reactant molecules that are combining, okay? So if we talk about the options, the first option is that the more number of colliding particles, more is the weight and difficult it becomes to cross the barrier. Now this statement is going to be incorrect because it does not depend upon the weight, right? It depends upon the molecules and their collisions. Okay. Talking about option 2, it says that the activation energy for many body collisions are very large. Now this is also an incorrect statement because activation energy and the number of molecules combining have no direct relationship, right? So therefore, this cannot be the correct answer. The third is that many body collisions have low probability. Now, this is going to be the correct answer, as we saw that in the case when A and B were colliding, we just had 2 molecules, they collided with each other. But when we have more than 2 molecules here, 3 molecules in this case, the probability of combination of these, or you can say the probability of collision of these 3 molecules is very, very less, right? Out of all the 4 collisions, only 1 collision will be the one in which all these molecules will collide. So many body collisions have very, very low probability. Okay. And talking about many body collisions are not energetically favored. They are energetically favored. This statement is going to be incorrect. They are energetically favored. They can happen, but the probability is going to be less, right? Therefore, the correct answer is option 3. That's all for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.